Let's go ahead and do another one. So, example 6. Let's do 3 variables now. Let's do f of x, y, z is equal to x times y times the sine of y and z. Okay, so be very, very careful here. Again, look at the function very carefully before you just dive right on in. So let's do df dx. So df dx, the derivative with respect to x, is going to be, well, notice we said you hold everything else constant, so you hold y and z constant. This sine function, yz, x is not in this argument. Because x is not in this argument, this whole sine of yz is a constant, and y is a constant. So the derivative of this is just plain old y times the sine of yz. So make sure you don't just automatically start taking the derivative and say, you know, x times the cosine of yz, because there is no x in the argument for the sine function, so it's just a constant. You treat it like a constant. Let me make my z a little bit clearer, I think, here. Okay. Now let's do df dy. Okay, df dy is going to be okay, so now you notice we have a y and we have a sine yz. So this is going to be a product function. So we're going to have to differentiate the way we differentiate a product. One times the derivative of the other plus the derivative of that one times the other. So it's like that. So we're going to take xy times the derivative of this, which is cosine of yz times the derivative of what's inside of there, because this is a chain rule, times z, right? Again, we just have to be very, very careful. And it's very common to make errors. It's not a problem. You know, that happens. That's life. Plus, now let's differentiate with respect, let's do the other derivative. So it's this times the derivative of that, plus that times the derivative of this. So the other things that are constant here, remember this is our function, this is our y, so it's these two. So it's going to be plus x sine yz times the derivative of y, which is 1. So that ends up being xy, oops, let's do xyz. So that is xyz times the cosine of yz plus x times the sine of yz. And I certainly hope that you are going to double check this for me. Now let's do the third partial derivative, df dz. df dz, so now we hold the x and y constant. So we end up getting, let's see what happens here. So if we hold the x and y constant, so that means these are constant. So we end up with x, y, cosine yz times the derivative of what's inside with respect to z, which is y. So that's going to equal x, y squared, if I'm not mistaken, cosine y of z. There you go. So this is df dx, this is df dy, this is df dz. The gradient vector, the gradient of f is equal to, the first component is df dx, the second component is df dy, and the third component is df dz. That's the second component, and that's the third component. That's all that's going on here, but it's very, very important. The gradient is a vector. Okay,